Well, first of all, I'm Marcelo. I'm the co-founder of ReviewPad. I'll do the talk in English in case someone here is not speaking Portuguese, and it's anyway good for you to hear some English from time to time. So today I'm going to be talking about, from my perspective, I was in your seat 17 years ago, and now I'm here, and I want to share some lessons with you, and also show you what we are building at ReviewPad, so that you can see a little bit what's coming in terms of innovation for software development. So I want to start talking about the systems. So it will become clear what these systems are, I hope, very, very soon. But it's fundamentally about where you are right now and where you can be. Okay? So where you are is quite clear. I mean, I am assuming that all of you are students from either the informatics engineering, it's always hard to translate lei, engineering informatica, or you are from, I guess, computer science degree. And so when I start thinking about what to say here, when I got invited, I was thinking, and back in the day when I was in high school, from time to time, there would be these people coming, like these students that graduated long ago, and what they come to visit the teacher. Okay, so, and it was always on a Friday. I don't know why, but it was always on a Friday. Sometimes these guys will show up, and they would go and talk with the teacher. It will get quite emotional, and I was always thinking to myself, I mean, what the hell was this teacher teaching them for them to come, years later and come and visit? And I was kind of thinking, okay, is it really different what they were taught and what I was teaching and what I was being taught? And so I have some kind of bad news for you. And the bad news is that 80% of my degree, 17 years ago, is what you are doing right now. So I went through all the courses that you have, from the first year to the third year, and it's pretty much the same. So I'm kind of with you. I can relate to what you're feeling through, even though it's been 17 years. And remind you, when I started studying here, there was no iPhone, there was no iPad, there was no 5G, 4G, 3G. There was nothing of the things that you have, but what the teachers or the faculty taught me, and I think it's pretty much the same teachers. I was talking before, JBB, JNO, Bell, all these people are still here, still teaching you exactly the same thing that they taught me. Think about that for a second. If you had a kid today, and 17 years later, that kid was going to university, and you would be thinking, okay, what is this kid going to learn at university and what you learned? And if you realize it was exactly the same, or 80% of it was the same, how would you feel? Okay, so think about that for a second. And so what I wish I knew about the courses, okay? So I did the degree that you're doing, almost exactly the same. And most of the time it was like, I don't know, why are you doing this course? What is this subject about? Studying some modern physics. What do I care about this? I want to code. I want to play some games. But I want to tell you about 3 different courses that I totally underestimated, that I should have paid attention, and I was not intentional. Like, I was a good student, but my first goal was to never fail a course. Because every time, like in the first year, it was like 5% of the students, only like 5% have passed all the courses. All the others have failed one. It could be, I don't know, programação imperativa. It could be something they would fail, but no one would have passed. They spent too much time in prash. I don't know what happened, but my goal was I want to not fail any course, and so it was really about I want to get out of here as soon as possible. Okay, that was the goal. So there are 3 courses I want to share with you. First year, logic. Okay? So I totally was like, Logica was like, I don't know what this thing is about. I didn't understand most of it. I passed, had a good grade, but totally disregard the course. And years later, I had to relearn it over and over again. And actually, I did a PhD. And my PhD, I was almost a logician. So almost I'm a professional mathematician. And I could have learned it, I could have saved some time instead of having to learn it over and over again. Second year course, and maybe this will be a bit shocking for you, the most important course is applied statistics. Okay? So forget about all the programming courses that you're being taught. You can learn that. That's easy. But statistics is super hard. If you don't learn statistics at a young age, your life is going to be worse than you think. And trust me, well, don't have to trust me. I'm just giving my opinion. But this is a course that if I had learned when I was your age, my life would have been much, much simpler later on. And there's another one. I don't know if this is a third-year course. Métodos numéricos. All right? So how to learn about optimizations. So if you think that your life is an optimization problem, if you kind of interiorize this, that what am I doing with my life? What am I optimizing for? And if you learn the tools about numeric methods and only optimization, you really get a much better sense of how to tackle a lot of problems that will show up with you in life. So I really strongly advise you, if you are taking these courses, or if you can retake these courses, but not just to pass, not to have a 10 or a 14 or a 15, but if you can actually have intentionally of, I want to deeply understand this, even if the faculty is not good, and trust me, we have all our complaints about professors. I heard that now you're at 200 per year. In my year, it was 117. And I remember the first class I had was functional programming with JBB, and I had to sit on the side. There was no space. I attended the first class, and it was at 8 a.m. or something like that. He was starting to lock the doors, and I was like, what's happening here? And I don't know what's going on. Next day, I fell asleep. I was like, okay, well, whatever, and I'll pass the course anyway, so I don't need to go. So I was going on the afternoon classes, and there was a lot of these classes that I just kind of went through, and nowadays, I would think very differently. So these are 3 things that I can advise you to think about. So what is the system that you are in? The system is this university, this degree. And there are pros and cons, okay? As in life, anything. So I'm going to talk about the pros. So what are the advantages of the system? So Steve Jobs wanted to create a bicycle for the mind, right? So a kind of playground. And so what you have is a system, and this system is a playground for the mind. You are not here to pass all your courses. You are here to experience something that you'll never be able to experience ever again. Because once you start a job, your life is going to be totally different than what it is right now. So enjoy this playground for the mind. There's another pro, is that everything is prepared for you. You don't have to think about anything most of the time. Your courses are predefined. In my year, I didn't have any choice at all. I know you have some electives, but when I started the degree, it was 6 courses per semester, and you couldn't choose anything. It was that. It was fixed. There was nothing that you could do. And now I think you can choose a little bit, but having this fixed degree, it was liberating. I didn't have to think, okay, what courses I want to take. It was just there for me. The third one is the people. It will become a bit clear later, but I never met students like I met in Minho, right? So all my friends that I have, and it's been 17 years, I still see them. And this hasn't happened with anyone else in other university that I've been to. What are the cons? Okay, not everything is roses. It seems to me that in 17 years, not much has changed. This is not good for you. For me, I'm okay. I already have my job, I have my company. But you have to go to the job markets very soon. If nothing has happened in 17 years, what's going on here? You have to wonder yourself about that. The second cons is the opportunities are scarce. It's not like you have a lot of stuff happening, a lot of opportunities going on to expose yourself. There is this event. You should take advantage as fully as you can from this type of events. And I don't know what the teachers have been telling you, but if they are telling you that you're going to be a software developer once you graduate, they are lying to you. Okay? So once you finish your degree, you're not a software developer yet. Okay? And you'll have a reality shock very quickly once you start working in a company. So I hope that this is not so hard, but I really want to try and help you as much as I can. And so what I did was I grabbed every opportunity that I could have. So I wanted to experiment with other systems. So I started here in Minho. Okay, Minho, what happens here? You have one year, it's 2 semesters. Every semester is 6 courses. No choices of courses, okay, everything is good. Student-professor interaction to the minimum. I don't know if they even know your name. there were classes that I don't know. This guy was recording a class in operating systems. I don't know if he's even still doing that. But I went there like 1 or 2 classes, and it was like, what's going on here? Quite crazy stuff. Cesium and Chaos was great. It was the only time I could actually interact with students, and it was really a good opportunity to like get exposed to other things outside of the degree, and it's really great to see that you are still doing that. In Portugal, there's a big problem, and the problem is that I experienced that. I don't know what's happening with you. There is no work culture, right? Students are supposed to study. I went to my parents and I said, okay, I want to work. I want to have a side job. And they were like, no. So the only side job I could get was to become like a researcher at the physics department, do some Fortran simulations, get some money. It was hard to make money on the side. It was hard to just have money to do other things like travel. And so what did I do? I escaped. I did Erasmus. And I went to Amsterdam. And so what happened was that I got exposed to a new way of doing things. They have 1-year class, 2 semesters, but every semester has something called the term. So you don't do the classes all at the same time. Every semester is divided in 3 different terms, and on each term you can choose classes. You can choose whatever you want to do on this term. Every like 2 months, 2 months, and 1 month, something like that. It's mostly electives, so you mostly choose, you build your own curriculum. And I got amazed by this thing that happens in the Netherlands, which is you can take any course from any university. So I'm studying at Minho. If I find that I want to go to Aveiro or to Porto to get like one particular course because they are very good at, I don't know, quantum computing, I can go and get the credits and do it here. I heard it's possible to do it here, but I don't know anyone that is doing it in Portugal. And in the Netherlands, this is very common. You find, I had classes with Tenenbaum, right? The guy who wrote the operating system book. It was just so easy. Operating systems, I don't want to do that with you. I'm going to go to Tenenbaum and have this class. And it was good. Nearly every student has a part-time job. Everyone I met was working as a bartender or doing something on the side and getting some money. It was very, very common. The system was done for that. Everyone was really incentivized to do it. And I got offered a job. This is a funny story I want to tell you. So the time I got offered a job was at the University of Amsterdam. And I was so excited, I said, I can work for free. And they laughed at my face. They're like, stupid Portuguese. Come on, no one is going to work for free here. So think about the mindset that I had compared to the mindset of the country. I was not happy to stop, so I kind of snoozed it. So I went to Utrecht. Actually, I went to Utrecht because here they were saying, I think it was JNO, they said, if you want to learn Haskell the real way, Netherlands is the place to go, Utrecht is the place to go. Okay, I want to learn Haskell the right way, so I'm going to go there. So I went there. How is the system there? 1 year, 2 semesters. Each semester, 2 different terms. Again, it's a different story than here, totally much more flexible. 1 term, you have X courses, mostly electives again. You pick whatever you want. If you want to become the Haskell guy, you just go and start doing all the functional programming courses that you can and just go to reading clubs. Have a lot more activity that you can do here. Cash is not welcomed in the Netherlands. So what does it mean? If you go to try and pay at the university with money, they'll say no. You only have to use a card. You have to go and find a card and use it. It was totally crazy for me because it was like 2009 and no one was using cards, no one was using cash. If you had like cash coins, you go and try to get a meal. They were like, I don't accept your money. So it was kind of a weird thing that had happened in terms of cultural clash. It was very easy to take a break from just the studies and just go and work at IBM. This was something that for me was very hard or even unthinkable in Portugal, right? To just have like a 6 months break, you get a good like internship job at a famous company, you go and live in Canada, and you work at a big compiler, right? So this was something easy to do there. So fun fact, Dijkstra's, you know Dijkstra, right? Everyone knows Dijkstra here. His nephew was teaching there. He was teaching a lot of courses. It was super fun. And I was talking a bit about the student-professor interaction before. Like here, it's to the minimum. There, I was going for lunch with him after every class. In fact, everyone was going for lunch with him. He would take us like the big duck and the little ducks behind. We would go and have listened stories about Dijkstra and what the crazy guy was trying to do. And you would eat like a sandwich, a piece of bread with the cheese. That's the Dutch lunch, and a glass of milk. That was very weird for me, like seeing a grown man drinking a glass of milk for lunch with a piece of bread and just cheese. But it was really cool.
I have to kind of disagree because the professors are always good. You mentioned something, he personally told me that Nottingham was the place to go for functional programming, but all the professors, most of all the professors, I keep good touch with them. I keep talking to them. Slovenia, for example, I maintain regular correspondence. Not I keep regular correspondence. It's not that rare. It's mostly a student thing, a student mentality.
Yeah, it could be. Yeah, it could be. I think, of course, I'm talking about my personal experience. I'm not trying to generalize or anything. Don't quote me. Don't go and say, Jotenyo, that guy gave a talk yesterday and he was complaining that you didn't know his name. I mean, he's not supposed to know my name, I guess, right? So I'm talking about my experience, right? And I'm saying, like, we were 115. Yes, JBB knows people here and there, but it wasn't like I went for lunch with them every day. So it wasn't that kind of relationship. That's what I'm trying to allude. So then I went to Turkey. I went to do a second Erasmus. I was not finished with Erasmus. So I went from Utrecht to Turkey. Went to the American University in Istanbul. Again, same system. It's basically an American university. Studying there or studying in the US is the same thing. 1 year, 2 semesters. 1 semester, elective courses. Campus was amazing. Living in Istanbul for me was like amazing. Like 22 years old, like going for a big city. And you have classes from top US faculty. So this is like the brightest of Turkish. Like, just think about this. If you want to reach this university, there is like 500,000 people applying, like doing the final exam at high school, and only the first 1,500 enter. Think about that statistic for you. And compare that, like the top students going here versus what's happening in other places. So it was really cool. And then I really understood what an impact of a mentor can have in your life, right? So having a mentor was really key, right? And I didn't have that until I went there. And finally, I went to Oxford. So in Oxford, I did my PhD. It was really cool. I can tell you some weird stories about JBB if you want, but not here, not being recorded. 1 year is 3 terms. Oxford is quite strange, the way they do the terms. The terms have funny names. It's all different. You basically have elective courses. It's very different to do a bachelor versus doing a master's versus doing a PhD there. But anyway, you have a tutoring system. A tutoring system basically means that you have 3 types of classes. You have lectures, you have labs, and then you have this thing called the college tutor. So a college tutor is, you have basically a private teacher. And the private teacher has classes with you for like 2 or 3 people. And it's not like here where you're like this thing and then I'm teaching you. It's more like you have all these layers and they take you by the hand and they teach you everything, like literally everything. It's quite crazy. And now I want to tell you a little story about why framing is important. So I heard this from a friend. So he got into a top US school. And then at the first day of school, I think that probably happens here, the dean got everyone together, all the students, and the dean said, okay, first of all, I'd like to welcome you and congratulate you on achieving this prestigious thing of entering this school. And now I would like everyone that was the top student in their high school to stand up. And everyone stood up. Okay? Everyone except my friend was the second best. And the lesson was, you were the top student before, and now you are equal to everyone else. And this is why framing is important. If I told you about 5 different universities I went to, but the fact that Oxford is ranked number 1 or number 2 doesn't mean much, if I'm truly honest with you. Okay? What it means is that, yes, I was able to go there, but there I was like everyone else. I had the same struggles, and it was not particularly special. And that's why I think really framing is very important. To know that you could have been the best in the past, but now nothing matters. And this applies to the opposite. If you're struggling right now, don't stress out so much, because things will get better. So what are the key takeaways I'd like to share with you? No one is crazy. People are just different. If you study in Utrecht, if you study in Oxford, or you study here, you'll have very different backgrounds, but no one is actually crazy here. And the second one is, if you are here, my advice to you is move. Grab every opportunity you can. For some of you who might think, okay, all this stuff that I learned is useless, I recommend that you read this book. It's called The Usefulness of Useless Knowledge. It really explains why, at sometimes, it's okay to learn something and not knowing why I'm learning this. Okay, the second part of the talk is the jungles. Okay? So what it means to be a software developer. What it means to be in the jungle. What is a software developer? A software developer is a communicator. If I have to translate, if you cannot communicate, you will not be able to be a very good software developer. So, what type of communications do you have? Lots of meetings. You are talking with people all the time. You are working in a team. You are writing specifications. You are actually writing things like, okay, how should I do this? You're providing feedback. You're saying, okay, I'm reviewing someone else's code. This code, it's good, it's not good. I think we should do it something else. You're providing feedback to specifications to some other people. And you're coding, okay? So these are the four things that you typically do on an everyday as a software developer. So let me tell you like a little story about why communicating, if it's not done well, it's kind of like screws people over. So there are two guys, and they're very good friends, and they like to hunt. And they're in the middle of the forest, in the middle of nowhere. And suddenly, one of them starts feeling bad and collapses on the floor. The other guy is like, oh, what's happening, what's happening? Like, gets in panic and calls 911. Operator picks up. 911, what's your emergency? Oh, my friend, I think he's dead. He's just collapsed. Operator is like, okay, just try to calm down. The first thing we need to do is to make sure he's dead. Silence, a couple of seconds, gunshot. Picks up the phone again, he's dead. Now what? If you don't know how to communicate, and if you say something and the other person listens to something else, and if he starts acting in this stupid way, bad things are going to happen. You laugh a lot about this, but sometimes when you're coding, you are putting lines of code into a product, and without you knowing, that product is going to an open source library. This open source library is going to go and be imported by some other company, and that software can go to space, as we see now with GitHub. You can find out if you're doing open source contributions that go to space. It can be done, I've seen many talks about how this professor from such and such university comes and says, oh, what's the best algorithm to do shortest path? Because drones have a battery of 3 hours. And with my algorithm, we can cover more kilometers than this current state-of-the-art algorithms. And you don't understand that, okay, what's happening here? This algorithm is being used in like some drones, and these drones are in some country that you hear on the news. So if you don't know how to communicate, how to listen to people and understand what's happening, bad things can happen. So let me show you, if my internet allows me, what I do on a daily basis as a software developer. You're typically in this, I guess you all have heard of Agile. There must be a course that someone teaches you waterfall and Agile, right? And this Agile is a religion. Like every religion, it's good and bad. And there's this thing called the Kanban. So when you go work for a company, you'll be part of a team. This team will have a project. And what will you do? You'll go, and for example, if you go for a GitHub project, you'll see something like this. It's a Kanban. And here, this is my team, right? So here we have a lot of stuff happening. And as a software developer, what I'll do is very simple. I know that I have a sprint. A sprint is 2 weeks. And I'm gonna pick items from this sprint that I'm supposed to do. And I'm going to create pull requests that fix this sprint, this ticket. So I take tickets that say, add a button to this application. OK, I'm going to take that ticket, create a branch, and I'll go a little bit more in detail about that. And then I'm going to create some code, and then I'm going to write some documentation about this, and I'm going to create a pull request. I'm going to review some else pull requests. This is what you do on a daily basis. You're not, the amount of coding that you do is very, very small compared to all the other activities, which is about what kind of code should I be writing. So I just wanted to give you like a very brief idea of what is coding, like what is being a software developer, and how different it is from what you're probably experiencing. The other thing I think it's important is to understand value. Okay? As a software developer, you need to understand value. This involves obviously having good technical skills, but here you'll have it. You'll learn everything that you need to know to be a good software developer. You need practical experience. So if you only stick to your courses, you're just going to be part of the system. There's nothing that you'll be able to show for compared to anyone else. And that's not good. You need to kind of get a better sense of what's going on. So have some practical experience. Build something. Build something with your friends. Do something. Diversity matters. And this diversity applies to everything in your life. It could be the language. It could be the people around you. It could be the diversity of what company you want to work for. Working for a startup, by experience, I worked from like startups that were in an attic to Google. Okay? And I have experienced all this range of companies from 5 people to 150,000 people. And I've also experienced companies which are in hypergrowth. A company that is hiring 20 people a week. It's totally different environment. Understand what you want for yourself. How do you want to be? In what kind of environment you want is super important when you're picking the next step in your career. And I think it's important to share this. You need to understand what market value is. What is your market value? When you ask for a salary, you're asking for a salary within a market. Even if that salary is like 1,500 euros today, what you need to understand is, okay, if I want to achieve 2,000 euros in a year from now, how can I increase my market value of 500 euros a month? And a lot of developers, they don't even care about this. When I talk about them about market value, they're like, I don't know. And I say, okay, if you want to increase the market value as much as you can, go to a startup. Don't go to a big company. Because in a big company, it's very hard to get promotions. So how are you going to show? Many times you're working in a company. At IBM, I worked with a guy. At some point, he came to me and was like, Marcelo, I'm frustrated. I was 21, by the way. He was like 40. The last 5 years of my life, I worked in projects. As soon as they were about to be released to the public, they got shelved. They never saw the day of life. This person has nothing to show for. Nothing to show for anyone else. So if you ask the question, what's my market value? Has it increased in 5 years? I don't know. Probably not. My key takeaway here is really start as soon as possible. Start thinking about this as soon as possible. Finishing a degree is not starting anymore. If you think that when you're finishing your degree, you have started to do something, nowadays, this means very little. I try to hire people, I don't even care if they have a degree or not. The only thing I care is, like, are they able to communicate? Can they code in an interview or not? Like, it's a very different skill set. Having a degree is almost, because I know, right now you know better algorithms than I do. And I have a PhD in computer science, so I should know everything. Statistic, it's more common for a person that finished undergrad to enter Google than a person with a PhD. If it's not like a specialized area. It's because you know the algorithms better. And the type of interviews that they have at Google is more suited for people that are just finishing undergrad compared to people that are finishing PhDs, which are burned out, and which have a very specialized knowledge about one particular area. So you know a lot more about certain things than I remember. And that's okay. That doesn't mean that you are better than me. Okay? It just means that you have a different way of thinking about it, but that's not really like a marketable skill. And I think it's important to understand that. Make a career plan. One of the key talks I attended at my university here was really a guy who came from IBM at some point, gave a talk, and he talked about his 5-year career plan. And I was like, what the hell is a 5-year career plan? I just want to finish all the courses of this semester. What is the guy talking about? And it was like no idea about what's happening. So these are hard questions. And as soon as you start thinking about these hard questions, the sooner you'll be in a better shape. Do not underestimate the power of networking. This is a common mistake for software developers. We are very introvert many times. We don't so much extrovert. We don't so much communicate or learn to communicate. So we don't have so much network. And then when something bad happens, we cannot have a network to rely on. Friends, get a new job very quickly, all sorts of things. Networking is very, very important. Money. Okay? Wake up. If you are doing something, wake up. If there's only one thing I want you to take care of, is what I wish I learned when I was at your age. So please try to pay attention for 2 minutes. I want to tell you a small story about how I understood that value, money, and time are intimately correlated. There's a shop in Porto that I really like to go. It's sort of this hipster, third wave coffee thing. A croissant costs like 3 euros. But if you go at 5:30, they close at 5:30, but if you go at 5, all the croissants that they have that they didn't sell, they start giving them away for free. So the price is not 3 euros or 0. It's somewhere, you need to understand the price, the value of the croissant is that you like to eat the croissant. The price that people ask you for it depends whether you have been there at 4 p.m. or at 5:15. And this is totally crazy. But it means something. It means that time is of its essence. So, I'm not legally, cannot advertise investments, but just take what it means. Most of you are below 25 years age old. If you start investing $200 a month today in the stock market, in like S&P 500, basically the American economy, just 200 per month. And if you keep doing that until you are 65, you'll be a virtual millionaire, probably. Nothing else you need to do. That's it. Now, I am here, 35. I didn't follow this advice because I didn't have anyone doing this for me. I didn't have anyone telling me what does it mean compound effect because I didn't pay attention in my statistics class. If I had paid attention in statistics class, I would have learned that. And I would have found out that, in fact, I should have been just saving a little bit of money and putting it into the stock market every day. $15 every day, and you are a millionaire. Nothing else. That's the secret. Did you know that in the US, it's more likely that you are a millionaire than you have a six-pack? Which is crazy. I found the statistic quite crazy. And this is probably because these guys are doing these kind of things, right? They are very quickly able to invest. Now, if someone is doing 45, then this person is, there's no time. So if you have a kid one day and you want your kid to be a millionaire, that's very easy. Just put 50 euros a month, put it into the stock market. When the kid is 65, he's a millionaire. Retirement done. Of course, this implies that the S&P 500 grows an average 7%, which is the case in the last 50 years, blah, 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 blah. But because it's 50 years, it's not like 10 years. We like quick bucks. Now, this is the thing that I got even more crazy about. What if you stop investing? You start at 25 and you stop at 35. You are still at a big advantage. So you really have nothing to lose. You have very little to lose. If you start at 25 and if you stop at 35, you are still going to make more money than I am if I invest the same amount and I start at 35. Okay, you can go back to sleep if you want, but please think about this. Because if I had known this when I was your age, my life would have been different. If you want a book recommendation about this, I recommend this book, Psychology of Money. It basically shows you that there's something important that as a founder, I'm learning nowadays, which is sometimes there's something between the decision and the outcome of that decision. Sometimes good decisions, they lead to good outcomes, but sometimes good decisions, they don't lead to good outcomes, right? The fact that I want to go from here to Paris, and I should take a plane because it's the safest mode of transportation, doesn't mean that the plane's not going to crash. Bad outcome. I still made a good decision, but I had a bad outcome. And sometimes you may do everything right in your life, but you still have a shitty result. But that's okay, because you did your best. You did what was best, knowing what you know at the time, because there are things you cannot control. Right now, most of you feel invisible. They're like, I can skip this class, I can skip this talk, I can go do that. Yes, you are invisible now, but very quickly you'll feel very differently. In a couple of years, you'll feel differently. So the life, I'm trying to make a difference. So I'll try to make it short because I think I'll run over time. But what's my mission? I want everyone to safely contribute to any code base in minutes. This is what I've been doing for the last 10 years. You're a developer. If you go to a code base with 1 million lines of code, I guarantee you it's going to take you more than a day to make a change there, even if it's a README change. Most likely. Hell, it's going to be even to take more than 1 day to set up your local environment to be able to even code and compile the code. This is the state of things today. We have lost control, total control about, I remember once Pruens, I don't know if he's still here, he was telling me about, computers are stupid. They are stupider than a 3-year-old baby. Not longer the case. Computers are smart. They are much smarter than we think. And then I listened to another guy, a Turing Award, and he was talking about, we lost control. We lost, like when I was your age, I understood hardware. I understood everything, the machine, everything. I understood it all. And now we lost hardware. And then he was complaining, we lost even software. There's so many abstractions nowadays. You run a Lambda in AWS, and you're like, what the hell is happening here? How is this thing running? No one knows. Not even they know. Once I went to Intel, I had a talk at Intel, and I went to talk with a guy, and this guy's job, I'm not joking. This guy's, so the Intel, you have like assembly, and there's like an instruction, and this guy's job was that instruction. He was the expert of the compare and swap. That was his thing. I know compare and swap. No one knows more about compare and swap than I do. And I was like, this is crazy. This guy's job was one instruction, one assembly instruction. It was crazy. OK, a little bit about Git. Who knows Git here? OK, that's good. So I'll go quickly. Robin and Kat are working in a team. They decide to use Git. Why did they decide to use Git? Anyone have heard about something else other than Git? You're not of the time of the SVN, of the subversions, of the centralized control versions. This is not your time. This is amazing to me. When I started university, Git had just barely started, showed up. And nowadays, GitHub is worth billions of dollars, which is not even Git. So they decided to use Git. And so in Git, you basically have a DAG. I can use the math jargon because you have all done all this stuff. So you have a DAG, you have a directly cyclic graph, and you have nodes. And some of the nodes, they are marked as particular types of nodes, which are commits, and they are branches, right? So they are the colored ones here. So what happens, one of the developers does a Git clone, is basically taking the thing that is in the shared, in the remote, and put it in locally. And then, it has this thing called the head, which is the tip. And then it's going to do a checkout. So the head is going to be now the bug 400. So it's basically this developer starts to work on a bug, a feature, one of those issues that I mentioned to you in that project. This is what happens. It's creating what we call a feature branch. So the developer is doing the bug, and then it does some work. It does the commit. The commit creates a new branch, right? This branch is now the blue branch. And nothing happens on the remote still. The remote's still the same because the developer is working locally. At the time, people were like, we developers, we don't have access to the internet all the time. What if we want to code on a plane? Now that's not a problem anymore, right? Everyone has internet all the time. So the developer does another commit. Then it does the push. When you do the push, now the remote repository is now updated. And now comes the issue. So the developer, Robin, here says, I want to propagate the changes from my branch back to the main part of the service. So I want to go from the branch 400 to the main. So I want to do this, right? I want to do the merge operation. And now Kat says, wait, no. I need to verify those changes, right? When you work in a team, this is not university anymore, where you can just do commit with the dot as the commit message and then push. Right? Now you work in a team, right? And you are being audited sometimes. So if you're trying to push code and changes to your software, they need to be reviewed. And so here comes pull requests. So pull requests are a mechanism popularized by GitHub to help merge feature branches. This is the inception of pull requests. Why are they useful? What was the breakthrough? Because they provide multiple things. An interface, a UI, where you can basically visualize the differences and review, actually, the product. You can discuss commands. Before, if people are still in the Linux kernel, anyone here knows how the Linux kernel works. You have to send patches over email, and the code reviews are done over email. Crazy. It was crazy 17 years ago. I cannot imagine how you feel about that, to review code by email. And then you can control the merge, right? So you can basically prevent people. If you join a company, I'm going to prevent the first week that you're not going to be able to merge, because I don't know, if you are able to even understand what Git is, right? So I want to control it. So this was very useful for open source contributions, right? So when I started work at university, there was almost no open source. Nowadays, open source is everywhere. But when I started, it's a big deal. It was a new thing. And so for open source contributions, because you don't know who is contributing to your project, you need to block the contributions from other people, right? So that was why pull requests were very useful. The important thing here is that it's a low trust mechanism. You're supposed to use pull requests when you don't know very well the other people. You're supposed to block their changes. And now the popularity. So last year, there were 170 million pull requests merged in 2021. Not last year because talk is a little bit old, sorry about that. But it's been exponential, right? So this explosion, so pull requests are used everywhere. I guess you have all used pull requests. Somewhere some professors probably forced you to open a pull request for some LE, some lab course. This thing is everywhere. So what's the workflow? Do you know what a CI is? Have you heard of the term CI, continuous integration? So when you open a pull request, the key thing that you want to do in your software is that you want to make sure that the build doesn't fail. Because if the build fails, you are blocking everybody. Everyone's going to complain about you. So you have this thing called the CI, the continuous integration, which makes sure that the project is building and the tests are passing. So it triggers a build. And then you basically have the review process. After the review process, you have some rework. You get some feedback about the changes that you're doing. And then you have this is a loop, right? So I basically open a pull request, say, OK, I'm going to add a button. And then the person from the UI comes and says, the button is too big. Just change the dimensions. OK, rework, continue, run the CI. And eventually I get approval. And what I'm going to do is I'm going to merge. So now we are here. Think about this is what I wanted, which is I did some work. And I want to put these changes into the software. And this is what's happening. Totally different story. In practice, what's happening from a very small intention, which is I made a change to the README, and all this thing is running. It's boring. Software development is boring nowadays. It takes time. It's boring. It's really boring. That's why I started a company. It's because it's boring. I was bored. When I was coding, I was bored. And you have automation everywhere, and then you are blocked by people. So what's the intention here? What I'm trying to say is that human collaboration is really the bottleneck right now. Is the fact that I have to wait for someone else to push changes into that software that is blocking me from being faster, from producing more. So, and the worst part is that it doesn't matter if you're changing the README, or if you're adding a database migration, or if you are completely rewriting the project. You go through this process every single time. Developers go through this multiple times a day, every day, OK? So what is the real fundamental problem here? We are using this pull request mechanism, which is, as I said, a low trust mechanism for open source contributions, and we're applying it on a team environment. But I know you. If I start working with you, I start to know you. I don't have to say I don't trust you anymore. So the problem is that this trust that you have is being undervalued because you're using a process that fundamentally doesn't rely on trust. So you have this superpower, which is the pull requests, and it's now a super bottleneck. So what are the consequences that you'll see when you start working? You'll have lower throughput, so you'll become slower. Worse than that, it takes typically, if you take like a normal pipeline, if you go to work for like a critical software, I don't know, one of the big companies that are outside, it takes nine days to go from working in an item to go to production. 7 of those days are going to be waiting. As I said, it's boring. There's a higher chance of failure rate because you are always asking you, OK, review my changes, review my changes, review my changes. You're like, OK, have you heard of this LGTM thing? Looks good to me. Have you ever saw that on GitHub? LGTM or SG sounds good. This is what's happening. People are like, OK, skim through the changes, looks good to me. This is really happening. I'm not even joking. I mean, this is really happening. We measure this in companies. 50 to 90% of the reviews are LGTMs. And you have higher developer frustration. Why is this a big deal? Big deal because softwares are paid a lot of money. They shouldn't be waiting. They should be productive. Or they should be, if they are not, they shouldn't be waiting in the sense that they should be at least doing something fun with their time. So, what is ReviewPad about? ReviewPad is about extending this idea that you need to apply this process all the time, regardless of the change, to have a flexibility. So Robin doesn't have to go through this same process every time. So suppose that what Robin does is a minor documentation change. No need for a review. What ReviewPad can do for you is to simply say, I can bypass the code review step, and you are able to freely push the changes directly to production, as long as the CI passes. Suppose that you are doing a deprecating of an API. Then what you can actually do is to say, OK, I want to push the change, and then I want the review to be done after the pull request is merged. You guys, you don't have enough experience, but when I say these words, the review can be done after the pull request is merged. For someone who is like software developer for like 5+ years, people they freak out. They're like, what the hell are you talking about? OK?
That's a bit dangerous, isn't it?
It's not dangerous if you have a good CI. It's not dangerous if you can codify what dangerous mean. And this is what we are trying to do. The third scenario is the critical database migration. So some things are sometimes you're doing critical changes, and what you actually want to do is to say, I want to put more humans into the process. So you want to say an extra reviewer is required. So what is this idea of fluid pull requests is to decouple the code review step from the rest of the process. So instead of doing this CI, review, merge, deploy, what you can actually do is something like this. I can review after the merge. So it's an extension with a language. So what we basically did, you know the term DSL, domain-specific language. What we have built is a domain-specific language where I can codify what my team is doing to say, OK, if I have a new joiner in my team, and this person has started less than 3 months ago, then I want to have a different code review process than if the person is an expert in the field. And this is apparently innovation. So think about the state of things right now. So I'd consider this to be an innovative tool. This should be done for free already. We as developers should have much more like freedom to do things. So the goal is to provide a consistent, transparent PR experience that minimizes the time developers wait for each other. So this is what ReviewPad is about. So it's a GitHub service that allows teams to implement these fluid pull requests. The specification lives in the GitHub repository, so it's like a file. It's like a file that really like specifies what you can do, what the team does. So when I open a PR, all these automations are done for you. It applies automations based on the spec. And it allows for this smooth transition from vanilla pull requests. So these pull requests are done currently on GitHub. So the core library is open source. You can go to GitHub. And if you're looking for a project where you want to be introduced to open source, this is a good project. One of the things I struggled a lot as a developer was to find projects which were willing to accept contributors. A lot of projects in open source say, oh, we are open source, but it's super hard. Go and try to modify the Kubernetes project on GitHub, and you'll see how hard it is to actually go and actually make some meaningful contribution. So we are waiting for your star, so help us, and your contributions as well. And so let me just show a couple of examples. I don't think I have time enough to show you like a real demo of it. So what can you do? You can specify, for example, pull requests that can be automatically merged. So what you can do is, wouldn't it be nice where I can say, OK, if my pull request only modifies markdown files, so then I want the merge to be done immediately. So I'm bypassing the code review step. It would be nice if I don't have to go. Right now, I guess when you open PRs, you have to go and tag your friends, like the guys you're doing the lab with. You have to go and tag them manually. What you can do with ReviewPad is to automatically assign them, so that you don't have to wait for it. So as I mentioned, one of the things you can do is to say, OK, I can define a group of new joiners. And I can say, OK, if the pull request, the author, is an element of the new joiners, I want to automatically assign a reviewer from the group of tech leads. So I, as a developer, don't have to worry about this. It was quite crazy. When I was at Google, I mean, there's so many automations in these companies that are not visible to the public. And for a small startup to even benefit, or even medium company to benefit from those automations, it's just super hard. They don't have it. The infrastructure in these big companies, the developer experience is 1,000,000 times better than what you experience in a normal company when you start using GitHub, vanilla GitHub. For example, you can do compliance stuff. So this is something important for you. Every time you open a pull request, you should have an associated issue to say, okay, what am I fixing here? I shouldn't just make changes without knowing what I'm doing. So this is something you can do with ReviewPad to say, okay, if I don't have any linked issues, then I want to add a comment in the PR itself saying, okay, this PR doesn't have a linked issue. So the developer knows, okay, now I need to actually put a linked issue. So it's helping you. This is a helper. Kind of way to say, okay, there is a way my team works, and I have a tool that helps me follow this way the team is working. So that's what it does, right? It puts a comment on your GitHub PR saying, okay, this PR doesn't have a linked issue. And now take a look at this. Suppose that you have special functions which are important for you. Okay? Would it be nice if you could simply go and say, okay, I have some Go code. Oh, this is terrible here. I have some Go code, and I just want to add a comment saying, okay, this is a critical function. And then what you can do with ReviewPad actually knows. We do static analysis of the code. So I guess you heard something about check marks. It's sort of similar, but different applications, what we're basically doing. So what you can actually do, or what it does is it understands, if I modify, for example, this line of code, that this line of code is in the context of the run action function. So it knows context. And then what you can do is to say, okay, I want to have a workflow such that if a developer opens a PR, and if it was annotated, the changes are annotated with critical, then I want to have a special code review process. Okay? So right now, you have to, as I repeat, the thing we are solving is right now your code review process is the same regardless of your changes, regardless of who you are. What we are offering is a possibility to free this, to allow flexibility. So I cannot show you because I think I'm running a little bit over time and I want to stop. I just want to finish by talking about your opportunity. This is your time. My time is passing, unfortunately, and your time is now. I think there are basically two different fields you should be thinking about more seriously. The first one is security. As I said, things are out of control. So if you are able to go and become a security researcher, if you're able to understand security and security vulnerabilities, you can have a very successful career right now. When I was in your position, people were telling me, if you know COBOL, you can go work for a bank and make a lot of money because no one wants to work with COBOL anymore. I could come here and tell you the same thing, but it's boring. So I think you should be looking at the future, not at the past and things that people don't want to maintain. And security will always be a concern because we as humans, we make mistakes. The second one is artificial intelligence. When I talk about artificial intelligence, I'm not talking about like this buzzword. I'm talking about statistical machine learning. Okay? So everyone is going to say I'm doing artificial intelligence nowadays. Everyone is doing AI. We're all AI companies. Okay? It's not true. Okay? Because AI has been here for 60, 70 years, right? Prolog is AI, right? So if you want to become a serious AI person nowadays, what you need to be investing is statistics, Python, and learning all these frameworks that people are doing, knowing what the large language model is. Who knows what the large language model is? Okay, but who has heard of ChatGPT? Okay, more people, right? So ChatGPT is nothing more than a large language model, right? So something that can predict what's the likelihood of the next word. I just simply say hello, and the thing says world, because it saw in the training data that statistically it's more likely that world comes after hello on all the corpus. If you want to get a good start at it, I recommend this book. It's 100 pages, so it's called 100-page machine learning book. It's very nice, very easy to read, and you get a feeling of what the field is now, so that you can start coding very quickly. So, where to find me? reviewpad.com. I live in Porto. I'm available to talk. I'll stay here a little bit longer. I have some T-shirts for you. So who wants to grab a ReviewPad T-shirt that says, yeah, something about automation and pull requests. And yeah, if any questions, let me know.
So I just wanted to know your opinion on GitHub Copilot. If you use it or you just heard of it or something else.
Yeah, I use it. I think it's a good tool because a lot of the code we write is boilerplate code. So it's like writing. In my time, we used to use Eclipse for Java. You guys still have Java, right? Object-oriented programming, I guess. You still have to buy the book by Mario Martins. Is this something that still happens? No? Okay. Thank God. Basically, in Java, you always have to say, OK, I want to create a new class. The thing creates me a lot of boilerplate code. I find Copilot to be like a useful tool for that, right? I'm writing some unit tests. The thing just starts filling out things that I know I have to type. So I use it for that. I think it's a good tool.
So it's accordingly to what language you use or you're programming? Sorry? So you are using Java, right? So you use GitHub Copilot just for Java or other?
No, I think it's a general model, right? Okay. It's a general model. So it's a little like, it's actually the same sort of tech. It's like large language models. So it basically finds out anything for you, right? So it just predicts the likelihood of the next tokens. And this was a big surprise. Like 5 years ago, we didn't expect these large language models to be so good as they are right now. OK, I would like to thank you. And again, feel free to chat me up and grab a T-shirt.